So next is the sort, array.sort. It seems very simple and straightforward, but it needs a bit of explanation. And since it's used a lot, okay, so you need to be aware of all the edge cases, right? So the call to array.sort sorts the array in place, changing its element order. Okay. In place is a data structure algorithm term, which means that it does not require additional space. So for example, if you have an array of length 10,000, it won't require that additional space to perform the sorting. It happens in place without any extra space complexity. Okay. It also returns the sorted array, but the returned value is usually ignored. The array itself is modified. Okay. So if let array equals to 1 to 15, and if we call array.sort on it, you will get a sorted array. Let's see. So here what I'll do is I'll make a couple of arrays. So I already have array 1, and let array 2 is equal to maybe C, sorry, they are strings, so C, D, B, and B and A, B, C, D, E, and finally E. Okay, finally E. Okay, so we have these two arrays. I'll simply run it. I will stop it, run it, and if I check array 2, I have this unsorted array. Now if I do array 2 dot sort, you can see that I get a sorted array A, B, C, D, E. The original array was unsorted, and the array that we get, the original array itself as well, so array 2 as well, is sorted in place. Okay. If we do the same thing with numbers, okay, maybe I'll add a couple of numbers here, 9, 11, 14, maybe, and I'll just check if I have the correct value. Yeah. And if I do array.sort, so we see that even though these are numbers, right, but they are sorted the way alphabets are sorted, right? So everything that starts with 0 is first, then everything that starts with 1, then 2, 3, 4, 5. When we are dealing with numbers, we really don't want this, right? We will be expecting something different, and we have flexibility to do all of that when using array.sort. But so when we just simply called array.sort with strings, it worked just fine. With numbers, they are a bit weird. Okay, just be aware of this, and this is a good starting point to move ahead. With the documentation of javascript.info. So the items are sorted as strings by default. So literally all elements are converted to strings for comparisons, and for strings, lexicographic, or the way they appear in a dictionary, that ordering is applied. So that's why 2 is greater than 15 when we compare it lexicographically. Okay, so by default they are converted to string. Now to use our own sorting order, we need to supply a function as an argument of array.sort, and it's important to understand that function. Function should compare two values and return either 1 or 0 or -1. So the function will compare two values. Okay, think of that as any two values. Okay, it will compare any two values. Usually they are stored in variables a and b. Okay, so for example, it takes these two values and you have to return something, and what you return is very important. You have to return either 1 or 0 or -1. If the first one, which is A, is greater than B, okay, if first one is greater than B, then you return 1. If first one is equal to the second one, you return 0. If first one is smaller than second one, then you return -1. So if the first value is greater than the second, return 1. If values are equal, return 0. If the first value is less than the second, then return -1. Okay. So for example, if you want to sort these numbers, okay, so then what you do is you pass in this particular function to it and you write the relevant logic. I think if I write them line by line, it will make a little bit more sense to you. Okay, so I'll take example of this exact same array. Okay, and now what I'll do is I'll just rerun it so that things are clean. Now if I check array, I have this unsorted number. Now array.sort, and we want to write our own custom logic for sorting. So I'll give it a function. That function gets, just think any two numbers. Okay, I'll store first number as A, second number as B. Now what I return from here, I have access to two numbers. Just think of it as any two numbers. For example, 9 or 11, two items of the array. This can be objects, this can be anything. Okay, and we can write whatever logic we need. So we will get this number, this sort function will be called a couple of times with different numbers, and depending on what logic we write here, the number will be rearranged or reordered accordingly. And we clearly saw here that if A is greater than B, the first one is greater, then we need to return 1. Okay, so here we can write if A is greater than B, we want to return 1. If A is equal to B, we want to return 0. Again, we don't really need the third one in this case, but let's still write it. If A is smaller than B, then we want to return -1. Okay, now let's see what we get. We get nicely sorted array, right? Even though it's number, it's sorted really nicely. So think of it as, don't worry about which number goes to A and B. Just don't worry about that. Think that if these two number goes in 9 and 11, what logic should I write? I'll give you one more example, then things will be a little bit more clear to you. Okay, I'll pause the recording and create an array of objects for you so that we can experiment with them. Okay, so let me pause the recording. So basically I am creating an array of 4 objects. Okay, I will rearrange these so that they are easy to reason about. Okay, so I simply typed out this simple array of objects. Okay, I paused the recording so that you don't see me typing these things, right? To save some time. So we have a nice array. It has a couple of objects. So it's an array of objects. Each item in the array is a JavaScript object. Okay, and they have properties like ID, score, and name. And you can clearly see that they are unsorted. So this is a very good example, friends. I'll solve them for you. I'll sort them in different ways, but I'll highly recommend that you pause the video and try to do it yourself. Okay, that will give you a lot of confidence. So I'll just run it. So I'll make sure that I have array 3. So we can see that array 3 is a nice object of unsorted, right? They are not sorted either by ID, they are neither sorted by score, they are neither sorted by name. So completely unsorted array we have. Now what I want you to do first is, using array.sort, I want to sort this array by its ID. So this should come first, this should come second, this should come third, this should come fourth. Let's see how would we do it. So array3 dot sort. Okay, then in the function, let's use arrow function this time. In the arrow function, we get A and B. Think of A and B as any 2 arbitrary value. Okay, any 2 items. Now, if A dot ID, if A dot ID is greater than B dot ID, then we would be returning 1. If A dot ID will be equal to B dot ID, then we will return 0. If A dot ID is less than B dot ID, we will return -1. Okay, let's see what we get. So we again get an array of 4 objects, but this time it's sorted by ID, right? So what happened? So we passed a callback function inside and it got any 2 objects or items one by one, right? So think that we got this object and this particular object. So this was stored in A, this was stored in A, and this was stored in B. Okay, so these are 2 objects. How do we access members of an object? Using a dot notation, right? So I checked if A dot ID is greater than B dot ID, then it should return 1. If equal, it should return 0. If less than, then it should return -1. And this logic helped the sort function decide which value do we consider as, smaller and which value do we consider as larger. Okay, so this is the logic. Basically, if A is, let me go to the documentation. If A is greater than B, we return 1. If A is equal to B, we'll return 0. If A is less than B, we return -1. I'll show you a couple more examples using the same array so that it's very, very, very clear to you. Now friends, I want to sort this array 3. Let me rerun it so that it's unsorted by score. So basically, this Abhay should come first in our array, Rahul second, third Vivek, fourth Basam. How do we do that? Again, array 3 dot sort. Okay. Then we get 2 items, A and B. A and B inside the callback function, and we return 1 if A is larger, because we want to sort it in the ascending order. So if A dot score is larger than B dot score. Okay, if A dot score is larger than B dot score, then we want to return 1. Since here we don't have any values that are equal, let's see what we get if we do just this. And you can see that it's indeed sorted, but there is a little bit of problem here, right? It's not sorted in 100% perfect way. Okay, so let's write the other conditions as well. So here I'll write if A dot, it's always, we will see as we move ahead in the notes, dot B dot score, we return 0. If A dot score is lesser than B dot score, we return -1. Okay, let's execute this and see what happens. So we get a brand new array, and this time it's properly sorted by score. The one with the least score is up and the one with the highest score is down. See how it works? Try to do the same thing for names. Okay, sort them by name. So A, so the name that starts with A should come first, then B, then maybe R and V, right? So this I'll leave up to you. So very powerful sort method. Let's move ahead with the notes, with the javascript.info documentation. So let's step aside and think what's happening. Okay, the array can be array of anything, right? It may contain numbers, it may contain strings, it may contain objects, it may contain whatever. And we have a set of some items. To sort it, we need an ordering function that knows how to compare the element. So an array can be an array of anything, and using this compare function, we are telling the sort how it should compare things. We need an ordering function that knows how to compare its elements. The default, if we don't provide any compare function, ordering function, then it's the string order. We know that, right? So the method implements a generic sorting algorithm. We don't need to care about how it internally works because it's an optimized quick sort or dim sort most of the time. It will walk the array, compare its elements using the provided function and reorder them. And we need to provide a function which does the comparison. Okay. If we ever want to know which elements are compared, we can always alert or console log A and B. Then we know that where comparison is happening. The algorithm may compare an element with multiple others in the process, but it tries to make as few comparisons as possible to reduce the time complexity. Actually, a comparison function is only required to return a positive number to say greater and a negative number to say less. So it's not strictly 1 or -1. It can be any positive number. If it returns positive number, that means A is greater. If it returns negative number, we say that A is smaller. In other words, positive means greater. We are talking about the first number, first argument, and a negative number means smaller. That is why we can use arrow function, because how this works. It's really interesting. So we are comparing, for example, two numbers, right? If A will be greater, if A will be larger, then A minus B will always return positive. If A will be smaller, then A minus B will always return a negative number. So we don't really need to write, more than this for a numeric comparison or reordering function. Okay, did you get it properly? So if we are comparing two numbers, say 5 and 3, let me show you. Let me show you so that it makes a lot of sense to you, because you will see this pattern a lot. We are talking about this array now. Okay. So one thing I have already shown you is, let me see if I'm able to get it. So we did this right here. And we were able to sort the numbers, right? Here in the documentation we saw that actually we just need to provide a positive number. So assumption is we want to sort in ascending order, smaller to larger. And if the first argument is larger, we need to, for sorting in ascending order, we need to return a positive number. If the first number is smaller, the first argument is smaller than the second one, then we need to return a negative number. Okay. The way we are doing it here is, if we are comparing, if A is more than B, then returning 1. If A is equal to B, returning 0. If A is lesser than B, returning 1. Now friends, tell me one thing. Just think of these two numbers, 9 and 11. Here 9 is smaller than 11. Okay. 9 is smaller than 11. So what will this function return if it gets 9 and 11? Since 9 is smaller than 11, it will return -1, right? Now think of these two numbers, 4 and 5. Not 4 and 5. Think of these two numbers, 14 and 0. Okay. A is 14, B is 0. What will this callback function return for 14 and 0? 14 is greater than 0, so it will return 1. Simple. Now tell me one thing, friends. What will simply 9 minus 11 return? Since 9 is smaller, it will return a negative number. What will 14 minus 0 return? What will 14 minus 0 return? It will definitely return a positive number if the first number is larger. So this entire thing that we have written here can be written in just one line, friends. So this entire thing can be written in just one line. Array.sort. Okay. Then an arrow function. It gets an A, it gets an B. And what does it return? A minus B. And we have a nicely sorted array. Right? This entire thing, this is kind of an algorithmic question, right? How, there is a bit of logic happening. The same thing is happening, but in much lesser number of lines. And if you get to work on a big code base, you'll be seeing mostly these kind of, callback functions. Now, if I want to sort it in a reverse order, it's very simple. I'll give it the reverse logic, B minus A. And now we see that it's sorted in the reverse order. Okay. So yeah, these things are not like very, very simple. It needs a bit of practice, a bit of, thinking about it, bit of playing around to get comfortable with it. But this is so important. You will use sorting so many number of times. You'll be using it with array of objects, array of numbers, array of strings. So it makes perfectly sense that you spend some time on it and try to get as comfortable with it as possible. Okay, let's move ahead with the documentation. So let's see what's written here. Remember string comparison algorithm? It compares letter by their codes by default. So for many alphabets, it's better to use str.localCompare method to correctly sort letters such as this one with an accent. Okay. So for example, what happens is that they are actually sorted by their codes. So for example, it will be 65, it will be something, right? So at times when letters have their accent, their code may be out of order. If they are all, ASCII digits like A, B, C, D, E, F in small or capital, it's fine. If they are just numbers, numerics, it's fine. But if it has anything more than that, then at times, their codes are messed up. So in the comparison function, you can do something like a.localCompareB. So what will happen is that the local compare will, return the positive, negative, or 0, depending on whether they should be, depending, on arranging them in the ascending order. Okay. So for example, I'll quickly show you. So I'll just copy this. Okay. So if I just type O string, something, any string, it can be any string, OWL, okay, greater than and, okay, so it gives us true, and which seems reasonable, right? But if we do something like this. Ostrich, where O has an accent, greater than and. It seems to be giving true, but at times, things do mess up. So the better approach would be, let me do another comparison. Then vim, okay, it gives true. And if we do same thing with, okay, so when we try to make a comparison between ostrich with accent and ostrich without an accent with vim, we see we have an unreliable result. Okay, so in such cases, okay, for many alphabets it's better to use string dot local compare. Okay, so since it's already a string, we can do local compare and we can compare it with vim and we get -1. And if we do ostrich local compare, we get -1. So it's much more reliable, right? So this is what is written here for several for many alphabets. It's better to use string.local compare. Okay, great. So this was, I know sort may sound a bit confusing. I've tried to make it as simple as possible for you. Okay, so great.